writing code is a funny thing. At first, the task looks very simple. We need to render a card. Then the business says, now we need the same kind of card for another entity. Then a third version appears. Somewhere we need a different header, somewhere a slightly different body, somewhere a footer appears, and somewhere almost everything is the same except for one small detail. And there's nothing unusual about that. That's how real products grow. Today the requirements are small, tomorrow there are more of them, and the day after tomorrow, that simple component is no longer so obvious to extend. And this is where it gets interesting. The problem is not that the component is bad by itself. The problem is that the requirements change, but the approach to the component stays the same. At first, regular props can be a perfect solution. Then there are too many of them. Then you want to assemble the component through composition. Then repeated scenarios appears, and factory starts to make sense. And then it turns out that ready-made variants are not enough, because you don't need to change the whole card anymore. You need to change separate sections. And that's exactly what this video is about, not patterns for the sake of patterns, and not the idea that factory or builder automatically make your code better. We will take a normal product task and go step by step through how requirements force us to change the approach. Where props are enough, where compound components help, where factory appears, why one factory can become too limited, and why at some point builder starts to make sense. So patterns here won't be textbook definitions. They'll be stages in the evolution of a component. Each new approach will appear not because it sounds smarter, but because the previous approach stops handling the new requirements comfortably. And by the end, we'll answer a much more practical question. How do you understand which approach you need right now, so the component stays understandable, extensible, and doesn't create extra pain? If you found this video interesting, please leave a like and drop any comment. It really helps the video reach the right audience, and if you want more breakdowns like this, don't forget to subscribe. And now, let's begin. Hello, my name is Eugene and I build front-end system with a strong focus on architecture, scalability and long-term maintainability. So from the business side, the task looks extremely simple. The project has 3 entities: a comment, a post, and a user. Each one needs to be displayed in its own card. The card should stay within the same design system, but in some places the header will be different. In some places the body will be different. In some cases an extra footer will appear. On the product level this sounds almost harmless. We just need cards for different entities. But from the development side the task is different. Don't duplicate code. Create new variants quickly, and don't rewrite half the project if the card design changes. And readability, of course, because extensibility without readability very quickly turns into beautifully organized chaos. There are many variants, many configurations, and after a while nobody understands which part is responsible for what anymore. And this is where the "let's just make one component and pass everything through props" approach starts to break. At first, it looks fast and convenient. Title, body, footer text, description, show avatar, has footer, is descriptive, line clamp, everything lives in one place, and everything can be turned on or off. But the problem is that props become the only source of truth for every version of the card. The post version, the comment version, and the user version all live on the same flat level. Settings get mixed, conditions get mixed, markup get mixed, and logic for different scenarios slowly ends up inside one component. So in the end, we don't just get a component with so many props. We get a component where different roles, different structures, and different rendering rules all exist on the same level. And the more requirements appear, the harder it becomes to understand which props belong to which card version. and which combination accidentally breaks an old scenario. This is where the first task appears. Move version management out of a flat props API and give different card variants a more understandable creation model. But before we go there, we need to keep one important thing in mind. Our base component already uses the compound components approach. For those who are on this channel for the first time, compound components is an approach where a component is split in small parts and then assembled through composition. For example, card can consist of card header, card body, and card footer. That's useful because we use the base styling and can build different structures from the same shear parts. But compound components give us building blocks, not ready-made assembly scenarios. If the post card, comment card, and user card are manually assembled for the same pieces every time, we still repeated the same composition, which header to use, which body to render, whether we need the footer, and which data should go there. So we move away from a props base code component, but we can still run into UI problems, just not at the level of basic markup anymore. Now the repetition lives at the level of repeated assembly scenarios. And it's important to frame this correctly. A prop-based approach is not bad by itself. If the component is simple, there are only a few variants, and the logic barely changes, props are the fastest and clearest way to control the component. You don't need factory, builder, or another abstraction layer if the task is already solved by a normal, readable API. Compound components also solve their own problem. They give you compositional freedom and let you build different structures from sheer parts. But when repeated card variants appear, plain props are no longer enough, and manual compositions is no longer enough either. We need a separate layer that can preserve ready-made creation scenarios without forcing us to manually assemble the same card again and again. And this is where the first popular pattern appears, factory. In the context of components, a factory is a component or function that takes some kind of signal, for example variant, and uses it to decide which version of the component should be rendered. So instead of keeping all conditions inside one large component, or manually assembling the same composition every time, we move the choice of a ready-made variant to a separate level. A simple analogy would be a vehicle configurator. You have one general category, but inside it there can be different models, a sports car, an SUV, a sedan. The general idea is similar, but the structure, capabilities, and available settings are different. The same logic applies to cars. There is a general idea of a car, but specific variants can have a different header, body, footer, and a different set of props. We can create card factory, pass variant into it, and based on that variant, the factory will decide which cards show, simple, standard, or descriptive. And what especially important is that each variant can have its own props construct, so props no longer live in one sheer flat space for every scenario. As a result, we get a sheer card factory that cares about one key property, variant. Then, through switch case, it selects the right card and passes the required props to it. And the cards themselves already have their own markup, their own logic, and their own construct. Repeated elements, like a header that appears in several variants, can be moved into a sheer component and reused. And notice one thing, I intentionally don't make the variants after domain entities like comment, post, or user. I detach the mess from the business model and move toward the structure of the card. Because today a simple card may only be needed for posts, but tomorrow a new entity appears, let's say task, and the same structure fits perfectly. And if the structure didn't change, you don't need to create a duplicate just because the business entity changed. And this is where factory works really well. It's great when we have clear and stable variants in advance. For example, pricing cards, basic, pro, enterprise, or notifications, success, warning, error. So scenarios where the business really speaks in ready-made types and we need to choose one prepared variant and get a predictable result. But in our case, The variability starts moving beyond the level of the whole card. The problem slowly moves inside the structure itself. The header changes separately, the body changes separately, the footer changes separately. And this is where Fatsuri starts to feel too rigid, not because it's bad, but because it solves a different problem. It selects a ready-made variant as a whole. For example, we already have a simple card, but now the business asks for almost the same card, only with a footer. Yes, we can build it from sheer blocks, reuse the header, reuse the body, move the footer separately. But the problem is not only repeated JSX. The problem is that for one small difference, we still add a new variant, a new contract, a new branch in the factory, and one more prepared assembly scenario. And at some point, it becomes clear. A factory of ready-made cards no longer gives us enough freedom. If we need to take the header from one variant, the body from another, and make the footer unique, we either create another new variant, or we start loading the factory with exceptions. So the next question appears. What if we need a model not for choosing a ready-made card, but for building a card from independent sections? In other words, what if we assemble the card not as one prepared variant, but as a configuration of separate parts, header, body, and footer? And this is where we move to the next pattern. Builder. So what is special about Builder? In our model, Builder doesn't have one ready-made preset for the entire card. It assembled the card section by section, header, body and footer. To build user card, we pass a header configuration into card builder, choose the required variant, and TypeScript immediately suggests the props available for that exact variant. The same idea works from the other parts. We can choose one body variant, configure the footer separately, and keep the header in its own configuration, so we are no longer tied to one prepared card. We don't need to create a whole new variant just because the header changed, and we don't need to manually duplicate the same composition through compound components. A new header variant appears? Great! We add a new header variant, but the other section remains untouched. The body keeps its own contract, footer keeps its own contract, header keeps its own contract, and this fits the ideas of single responsibility and open closed much better. Each section is responsible for its own part, and new variants can be added without rewriting the whole card. But there's one important detail here. We are not building the component using only one pattern. Card Builder does work as builder because it assembled the card from section configs. But inside each section, the familiar factory logic still appears. We choose the section variant and the system decides which specific header, body or footer should be rendered. In other words, these solutions combine several approaches at once. Builder is responsible for the overall card assembly model. Factory helps choose specific variants inside the sections, and compound components remain the building blocks these sections are built from. And this is where patterns stop working like separate tweaks and start working like layers of one system. As a result, we get a more flexible model. We can add a new header without creating a new card. We can change the body without touching the footer. We can extend individual section without turning the whole component into a set of exceptions. So Builder works well when variability no longer lives at the level of one ready-made card, but inside the structure of that card. But again, this approach works well only when you already have a more or less stable design system, meaning header, body and footer actually have understandable variants, not a situation where every new case needs a custom class, a custom specific fix, and one tiny exception in one specific place. If those exceptions appears constantly, it doesn't mean Builder is bad. It means the component or the design system is not ready for that level of abstraction yet. And even in those cases, Builder can be extended. If you need precise customization for one specific part, we can use slots or slot props. Don't turn the whole section into a new variant, just give the developer a way to replace or fine-tune the exact fragment they need. Builder doesn't have to cover absolutely everything through configs. His job is to hide repeated structure and provide a nice API where scenarios are already stable enough. But the main thing is not to overdo it. You don't need to turn every element into a separate config. If something inside a section can be solved more simply with a regular probe, a slot, or slot probes, do that. Good architecture doesn't have to be maximally abstract. It has to be flexible enough for the task. And if the project is still at the MVP stage where requirements change all the time, I wanna start with a heavy builder at all. Often, it's better to use compound components and slots. They give you more freedom, fewer predefined rules, and let you move faster. Then, when the scenarios stabilize, repetition becomes obvious and you understand which variants are actually needed. You can add factory or builder to remove duplication and make the behavior more predictable. And remember, a good approach is not the one that looks more complex or has a smarter name. A good approach is the one that works in your specific case, covers the business need and doesn't create extra pain for development. Thank you for watching and I will see you in the next video.